Okay, so we're looking at prime factorization, and let's remind ourselves quick again about what that means. If I've got the number 15, then that number can be broken down into two numbers that multiply together to get it, so 3 and 5. And you'll notice that both 3 and 5 are prime numbers. That's numbers that can only be divided by themselves in 1. If I take 40, whoops, lose my whole page there. If I take 40, and I split it up into stuff that it can be multiplied by, let's say like 5 and 8. Okay, 5's prime, but 8's not prime. 8 can be split up into two numbers that multiply together. You get 2 and 4, for instance. 2's prime, but 4's not. It can be split up into 2 and 2. Well, now those are prime. So what we found is that these numbers here, 5, 2, 2, 2, and 2, all multiply together to get 40, and they're all prime numbers. And these are prime numbers. And so basically the idea was any number can be written as a product, numbers multiplied together of prime numbers. So we did this one earlier. Here was 40. We used a different pair, 4 and 10 instead of 5 and 8, but it doesn't matter. You still get 2, 2, 2, 5. So what I'm going to show you is what I call the ladder method. And honestly, it doesn't matter what method you use for finding the prime factorization. We're just learning another method here. So here's what this looks like. First of all, what you need to do is write down a list of the first few prime numbers. I'm just going to make a list here. 2, 3, 5, 7, 11, 13. Of course, it goes on forever, but I've made a list of those. So here's what I want to do. I want to start back with 40, and I'm going to start dividing it by numbers, and I'm specifically going to divide by prime numbers, and I'm always going to start with the lowest one first, and you'll see why I do that in just a second. Okay, now if I divide 40 by 2, it looks kind of like this. Okay, but then I get 20 up here, and the problem is I'd like to keep dividing, and I'm out the top of my page now, so I'm kind of stuck. So what I'm going to do is just this. I'm going to flip over that divide sign and put it this way. Okay, I'm still dividing 40, and I'm dividing it by 2, and what do I get? Well, I get 20. Well, now let me ask this question. Can 40 be divided by 2 again? Well, yeah, so I'll do that. So I get 2 again. What do I get? 10. Okay, can that be divided by 2? Yeah. Okay, I'll do that. Okay, can that be divided by 2? No. How about 3? No. Well, wait a minute. It's prime. It can't be divided by anything except itself and 1. So I've now found all the prime numbers that multiply together to get 40. They're 2, 2, 2, and 5. And the nice thing, and the reason I like this so much, is because I started with the lowest one, I get them all lined up in a row. The reason I didn't like, for instance, this method on the tree method as much is I might get them in different orders, or I might have them all mixed up here. Like here I had 2, 2, 3, and 7. I might lose one. Okay, for me, the reason I like the ladder method is it lines them up in a row. So let me show you another one here. Okay, again, I need my list of primes: 2, 3, 5, 7, 11, 13. Okay. And let's try 84. So I'm going to ask the question, is it divisible by 2? Well, yeah, it is. So do that. And I got my divide sign upside down just so I can work down the paper. 84 divided by 2 is 42. Can that be divided by 2? Yeah. So do it. 42 divided by 2 is 21. Can that be divided by 2? No. So check the next number. Can it be divided by 3? Well, yeah. Okay, and I get 7. Well, 7's prime. So now I've got my list, 2, 2, 3, and 7. I don't have to worry about putting them in order. They're already in order for me. So let's try another one. How about 128? Okay, 2, 3, 5, 7, 9. I usually, 9, nice job. Usually I write 2, 3, 5, 7, 11, 13. Usually I write these on a separate piece of paper. So I'm going to start with 2. It does divide by 2. I get 64. That divides by 2. I get 32. That divides by 2. I get 16. That divides by 2. I get 8. That divides by 2. I get 4. And that divides by 2. I get 2. 2 is prime. So here's my list. 2, 2, 2, 2, 2, 2, 2. I'm all done. So I like the ladder method better, but if you don't like it, that's fine. It doesn't bother me which one you use. Okay, so I'm going to do a few more here. Let's start with 125. Okay, can't be divided by 2, can't be divided by 3, but it can be divided by 5, so let's do that. 5, 25, that still divides by 5. You get 5, and 5's prime, so there's your list, 5, 5, 5. Okay, how about the number 150? Okay, well, it divides by 2, so you get 75. That doesn't divide by 2 anymore. Does it divide by 3? Well, 7 and 5 is 12, so yeah, it divides by 3, and you get 25. Does that divide by 3? No, but it does divide by 5, and you get 5, and 5's prime, so 2, 3, 5, 5 is your prime factorization. So you'll see that I really like this better, and as you go on, if you're taking my classes, you'll see me use the ladder method a lot more than the other method. So let's do one more. Here's 770. Okay. Does it divide by 2? Well, yeah. You get 340. No, you don't. You get 335. You don't even get that. All right, I must be tired. So 770 divided by 2 is 385. I knew that. Okay. Does that divide by 2? No. Does it divide by 3? Well, check it out. 3 and 8 is 11, plus 5 is 16. Nope, doesn't divide by 3. Does it divide by 5? Well, yeah, it ends in 5, so let's divide that by 5, and you get 77. Okay. Does that divide by 5 again? Well, no, but does it divide by 7? Yeah. You get 11. And 11's prime, so here's your prime factorization. 2, 5, 7, and 11. So for me, the ladder method is just a quicker method of using, finding the prime factorization of a number. I don't care, honestly, whether you use the tree method or the ladder method, whatever floats your boat. All right, that'll do it.